are having a normal blood versus a sickle cell blood absorptions at different wavelengths were given, and the black one is normal blood, how it is absorbing the different wavelengths we are showing, and the red one is nothing but sickle cell blood disease, and that absorption is also given at different wavelengths. So here we are we have identified around 430 one particular wavelength, and then here we are identifying around 720 the another wavelength. And if we observe the ratio of the normal blood is very high when compared to the sickle cell, and in order to have more clarity, what we did is we have taken the other wavelength also. That wavelength is at this particular point and again at 720. So these three waveforms, three wavelengths we are using, and we are taking the ratios at different wavelengths. Okay. And the main question arised is here we are able to detect only the sickle cell versus the normal blood, but at the same time the question arises how to detect anemia, because sickle cell anemia is also there and then normal anemia also is there. So in order to identify the normal anemia, we have used the magnetic attraction property of the sickle cell, and whereas in the normal RBCs they are not oriented when the magnetic field is applied, and but when the sickle cells they are there, they will be oriented in a straight line, and the absorption will be very high as they are oriented in a straight line. But whereas with the normal blood cells, in the enemy cases the RBCs they will be less, and at the same time here there are certain gaps. Through the gaps the absorption, one side LED light will be there, and on the other side we are measuring the absorption. So as the gaps they are there, the light can pass through and it will be reaching the sensor. So this particular property also we adopted in order to differentiate the sickle cell versus normal anemia. Okay, and finally coming to our equipment, this thing here we are using 4 different wavelengths, that LED source, and at the same time here we are having the sensor photo detector, and these LEDs will be glowing one after the other at a predefined rate by the microcontroller. And here we are taking the absorption from the photodetector. The photodetector output is amplified and filtered in order to avoid noise, and at the same time here the signal will be provided to the microcontroller, and the microcontroller itself will be selecting the wavelength, and so at that particular point of time what is the output, that output is taken to the microcontroller, and microcontroller will take the absorptions at different wavelengths, and then it will calculate the ratio, and based on the calculated ratio will be saying whether he is normal or sickle cell. And at the same time, in order to differentiate the anemic cases from sickle cell cases, we are having an electromagnet, and that's also under the control of microcontroller. So microcontroller will excite the electromagnetic coil. So on exciting the electromagnetic coil, a magnetic field is generated, and that magnetic field will orient the sickle cells if they are there, and if it is a normal enemy case, the orientation doesn't take place, so absorption will be different. So that particular property also used, and then here display unit will take the ratios, and it will ultimately say only whether the person is sickle cell anemic person or was normal anemic person, or was the just normal. Okay, so these are the waveforms obtained by our device, and at 3 wavelengths we have shown here, and okay, and apart from this we are also using certain other wavelengths, but here we have showed 520, 940 and 660 nanometers, and these are the absorptions also, they are different for the same particular person. Okay, and this how the basic principle and then the output waveforms are shown here. And coming to the equipment part, the equipment is coming to the equipment. This is the benchtop model what we have designed. This is a prototype model, and this prototype model is having here the finger probe, and in the finger probe here different light sources are there on this side, and here we are having sensors. And in order to avoid the ambient light, we adopted the screening, and from this the controller and the other power supply part is built into this. And at the same time we are instead of using electromagnetic excitation, we are using the normal magnet. Okay. And we can also automize this particular electromagnetic principle instead of the natural magnet. And at the same time here we are having the different outputs. Here we can observe on the CRO. This is not needed once the product is finished. And at the same time, after calculating all the ratios and all the things, here we will be getting finally the output on the LCD, saying whether the person is normal or anemic or sickle cell person. When we press the button, the signal will be taken from this, and at the same time it will take all the ratios, and then processing will be starting. And once processing is over, then it will indicate whether the person is normal or abnormal. So here I put my finger, and from the the different absorptions are taken, and then processing is going on. Now it's and